Hi everyone, welcome to this new lecture of hydraulic machine. In this lecture, we'll solve a problem on force exerted by the jet on a stationary curved plate at one end tangentially when the plate is unsymmetrical. Here, the plate condition we need to consider unsymmetrical and the plate is stationary and curved. Okay, and the jet of fluid is striking this plate with tangentially at one end. Okay, so the similar conditions we have derived the equation in our last video lecture. So you can see how the equation was derived for this, how the force exerted by the jet on the stationary curved plate at one end tangentially when the plate is symmetrical and when the plate is unsymmetrical. But here the problem is given based on the unsymmetrical conditions. Let's find out from this question how to identify whether the problem is symmetrical or whether the problem is unsymmetrical, and whether the problem is based on the curved plate or flat plate or inclined plate, or whether the problem is belongs to stationary or moving. So in the question it is given a jet of water of diameter 75 millimeter moving with a velocity of 30 meter per second strikes a curved fixed plate. Here it is given. So the plate type is curved and plate motion is fixed. So it is fixed condition, stationary plate. At one end at angle of 30 degree to the horizontal. So here we can see the plate is curved, fixed, and the jet of water is striking this plate at one end of tangential. The jet leaves the plate angle of 20 degree to the horizontal. Find the force exerted by the jet on the plate horizontal and vertical directions. So up to now we understood that the plate is curved, stationary and acting at the tangentially. So now how to identify the symmetrical and unsymmetrical? For symmetrical and unsymmetrical, I told in the last lecture, if the angle made by this jet of water tangentially at the inlet and outlet condition both are same, then it is symmetrical. If both angles are different, then it need to be considered as the unsymmetrical condition. So here also given the same thing. At inlet condition, it is given 30 degree, and when the jet leaves at the plate at outlet condition, it is given 20 degree. So both angles are different. That means it is an unsymmetrical cases. So let me first to draw a diagram here so that we can understand. Suppose this is a plate is there, a fixed plate, you can consider this one. Okay, and the plate is fixed by hinges of two sides. You can see these are the hinges are there which is fixing the plates, and the jet of water which is striking here. Okay, and this one you can consider this is our x-axis, and the jet of fluid which striking this plate at one end of the plate. This is one end, this is another one. So this end we can consider this is our suppose inlet, and the other end we can consider this is outlet. So the jet which is striking this plate and leaving at the outlet condition. So the jet which is striking here with a velocity v here. Okay, this is the velocity v which is going in this along the plate we can see here, and the same velocity is coming out if the plate is smooth. That also need to be considered. The plate is smooth condition. So what is the energy is there? There is no loss of energy in the fluid. So the same velocity is coming out. Now the velocity of this fluid which makes an angle to the horizontal in the sense to the x-axis. So this is the angle, this is the jet of fluid which is v, and this is we can say x-axis, this is y-axis. So this angle is theta here, and the same velocity which leaves at the outlet condition, and this is theta equal to, it is given 30 degree, and here at outlet condition it is phi. Okay, outlet condition is phi, and phi equal to, here it is given 20 degree. So we need to find out the force exerted by the jet on the plate on horizontal condition and vertical condition. That means we need to find out the force Fx, and we need to find out the force in the Fy. So let's find out, first write down what are the data given here in this question. So for the solution, let me write in the solution part. First we need to write down the data given. So in the data given, first one, diameter is given. So you can write this is diameter d equal to we can write this is 75 millimeter, and the 75 millimeter we can convert into meter, so that is nothing but 0.075 meter. And from here we can identify the value of area also. So area equal to A equal to, we can write this is pi by 4 d square. This is pi by 4 d square, and we can calculate the value of how much is here. Next thing is given velocity of the fluids of the jet is given. Velocity of the fluid jet, that is V equal to, it is given 30 meter per second. Similarly, the jet makes an angle. You can see at one angle, the jet which strikes the curve plate at one end, at this point, this is, as I told you, this is 30 degree. So you can write here angle at inlet. That means angle of the fluid jet with respect to the x direction, with respect to horizontal, that is nothing but theta. So that is given 30 degree. Similarly, the angle at the outlet, I can write here angle at the outlet, that is nothing but phi. Phi you can write here 20 degree as per the question given here. Now this one, these are the data given in this question. Now what we need to find out? We need to find out here the force exerted. Now the force exerted by the jet in the horizontal, that means Fx. So Fx equal to, we know that this is rho a v square, and the formula is this is cos theta plus cos phi, bracket close. Similarly, the Fy equal to, we know that this is rho a v square, bracket star, and this is sin theta minus sin phi. Okay, these are the data. Now here, as you can see, we need to find out rho value. Okay, rho value is not given. We can consider because the liquid is given water. So rho equal to, this is 1000 kg per meter cube. Now area we need to calculate here. So area we can calculate with the help of calculator. So this is 0.075 square, multiply pi and divided by 4, pi d square by 4. So this is the answer we got here, 0.0044. 0.004417, some value we got here, this one. And rho value given, velocity is given. Just put the value, all these things here, we can get the value final. This is 1000, and area we got here 0.004417, and velocity square, that is 30 square, and multiply of cos theta, cos 30 plus here it is cos 20, bracket close. Similarly, here also we can write the same thing, just we need to change the value of psi, 4417, and this is velocity square 30 square, bracket star, and this is sin 30 minus sin 20 degree. And this one we need to solve it by the help of this calculator. So first of all, I'll write here, I'll do one thing. I'll find out the value of this 30 cos 30 is 0.866. So this one I can write here, this one 0.866 I can write here, 0.866. This one cos 20, how much? Similarly 20, and this is cos 20, 0.939. So this is 0.939. Similarly, at a time you can calculate the value of sin 30 also. So sin 30, 0.5, 1 by 2, that is. So you can write this is 0.5. And similarly, we need to find this is 20. So the value of sin 20, 0.342. 0.342. Here, this is 0.342. So all the value we got here, finally we can write this equal to, now I'll do one thing, I'll start from here, 1000 multiply 0.0044, this is 17 is there, so 17 multiply 30 into 30, this much. Okay, now we can write into bracket start 0.866 plus 0.939 0.39 bracket close. Answer 7175. 7175.4165. So this one you can write 717.5 something by the 4165. Yeah, 4165. This much Newton is there. Okay, similarly this also we can calculate in the y direction. So again the same repetition we need to do. This is 1000 multiply 0.004417 and multiply this one 900 exactly. Now into bracket start, and this is 0.5 minus 0.342 bracket close. 628.09. So here we got the value. This is 628.01 or something we got here, this much Newton. So this is our final answer, and this is our answer of this. So I hope you understand how to solve it. Only you need to we need to do here, we need to just remember this formula in the fx in the f in like force exerted in the x direction, force exerted in the y direction, and remaining things we can easily do it. I hope you understand. Still, if you're having doubt, query regarding this, you can give a comment on the comment box. Thank you all.